In Group 7, it's me, Alyssa, Taichi, Thorin, and Sophia. In this lab, we are understanding stoichiometry and concepts of it, including limiting reactants. The chemical equation being 2 moles of KOH plus CuSO4 equals K2SO4, which is an aqueous solution, plus CuOH2, which is a solid solution. Stoichiometry is the study of quantitative relationships between reactants and products in a chemical reaction. The law of conservation of mass states that mass cannot be created nor destroyed and proves this by predicting the amounts of products formed. A limiting reactant is a chemical reactant that is needed to form a product and is fully consumed in the reaction. An example of this would be making a sandwich. You need 2 slices of bread and 1 slice of cheese to make 1 sandwich. If there are 12 slices of bread and 5 slices of cheese, the cheese would be the limiting reactant because it is fully consumed and limits how many sandwiches or products you can make.
Our lab group was provided with 2 burettes, 2 funnels, 2 beakers, 8 test tubes with a test tube rack, a graduated cylinder, and a stirring rod. Before conducting the experiment, it was very important for us to sanitize our equipment with distilled water to have an accurate outcome. To begin, we dispense 5 milliliters of 0.1 molar CuSO4 in each test tube. Then we dispense 0.2 molar KOH in every test tube, each increasing by 1 milliliter after another. We then leveled out the test tubes to be 13 milliliters each by adding distilled water. After evening, we then stirred them thoroughly. After 15 minutes, the precipitate settled at the bottom. Then we were able to measure their heights with a ruler and see the trend.
Before we even started, the copper 2 sulfate solution had a distinct blue tint, while potassium hydroxide was completely clear. When we started mixing, the solution turned cloudy. In test tubes 1 through 4, the precipitate increased in height as more potassium hydroxide was added, appearing baby blue with a soft powdery texture. In test tubes 5 through 8, the precipitate plateaued despite additional potassium hydroxide, developing a deeper blue, translucent glass-like appearance.
Results for that test tube 1 measured in at a height of 7 mm of CuOH2 precipitate, test tube 2 at a height of 11 mm, test tube 3 at 12 mm, and test tube 4 at a height of 41 mm. Test tube 5 reached 70 mm of CuOH2, test tube 6 reached 77 mm, test tube 7 reached 79 mm, and test tube 8 at 75 mm. As the amount of KOH increases in each test tube from 1 through 4, the amount of CuOH2 being produced increases as well, which means the KOH is determining the amount of this precipitate. However, when the amount of KOH exceeds the amount of CuSO4 in test tubes 5 through 8, the amount of precipitate starts to level off now that the CuSO4 is the new limiting reactant.
Regarding our lab, we used our results from trial 1. Referring to the graph, you can see that there is a leveling off in the precipitate. This trend was seen the same in our second trial, with tube 8 leveling off and decreasing. One of our errors that we made was that we measured our products too soon and not letting it sit for a while. However, regardless, we were able to produce the same trend and results in both trials.